Hi there, folks. Today we're looking at volumes of prisms and cylinders. And volume is just how much space any particular figure occupies, okay? And so sometimes we'll also think of it as how much stuff will something hold, like how much stuff fits into this thing, okay? But again, that's talking about how much space the thing takes up, including like the inside and outside overall, all right? So that's volume. The volume of a prism or a cylinder, really the volume of any of these things is just the area of the base times the height, okay? And really it's the kind of the same concept that, prisms and cylinders, when you look at these, you could find a formula for the volume of a cylinder that's going to involve pi and that kind of stuff, but it's really just the area of the base times the height. So a cylinder, you might see this formula of volume equals pi r squared h, okay? Which really is saying the same thing. It's area of the base times the height. It just so happens that with a cylinder, the area of the base is always going to be pi r squared. It's always the area of a circle, okay? And so you could use this one for the cylinder if you would prefer. But again, it's the same thing, all right? So generically for a prism, it's area of the base times the height. For a cylinder, it's the same thing, but you could use the more specific formula if you would like, okay? If we look at something like this guy, it says find the volume of each. And, with some of our prisms, we have to make sure that we identify the base correctly. Remember, the base of this thing is the two faces that are parallel and congruent, okay? So the two faces that are parallel and congruent. With this particular example, any of the opposite faces are parallel congruent. So I could call this set the base. So maybe this guy down here and this guy up here, these are the bases of this thing. And so if I look at those as the bases, the height will always be the distance between the bases, all right? And so, just be careful here. If I had used these other two sides, I could say this guy and this guy are the bases of this thing because they're parallel and congruent to one another. And if I use those two as the base, well, then this is the value I have to use as the height because it's the distance between those bases, okay? But again, it makes the most sense for this one, and I think it's easiest to think about if we can use kind of the top and bottom. Just be aware that we might have to rotate the shape in order for the bases to be top and bottom and the height to be vertical, okay? And if that makes you more comfortable, yeah, you might have to rotate the figure. You might have to change the orientation a little bit, okay? And so if I look at these and say, hey, you know what? I'm going to use the top and the bottom as the base on this one. Those are two faces that are parallel and congruent. And so the area of the base, I just find the area of one of these bases. So the area of this guy down here. So the area of that thing, when I talk about the volume, well, that would just be 4 times 2. That's the area of this base. And then if I'm talking about the height is the distance between the bases. Well, that's this measurement right here. That's measuring the distance from one base to the other base, okay? And so that's the height of this thing, which is 5. And now I can just plug away on this thing, okay? You can use a calculator if you need to. Gives you a 40, and that's going to be cubic feet this time, or feet cubed, okay? Because when we're measuring volume, we're literally measuring little tiny cubes that would be like 1 foot by 1 foot, okay? The other thing for this particular prism, when you have a box like this, a rectangular prism of any kind, we also have a special formula for this one. You could say the formula for the volume of this guy is just length times width times height, okay? And so you'll see that formula for the area of a rectangular prism as well. But notice it's the same thing. If you look at the length, width, and height, it's 4, 2, and 5. It's literally the same 3 values that I just multiplied, that I just used when I did area of the base times the height, okay? So that volume is area of the base times the height. That formula is a little bit more generic. Some of the specific shapes might have a more specific formula if you encounter these in other scenarios, okay? If we look at this one, once again, this is a cylinder. And so with a cylinder, remember the base are these circles. So these are the bases. So this guy down here, and then this circle down here that we can't see the whole thing because the cylinder is resting on it. But the area of those bases, we're going to use that formula pi r squared. So the volume is area of the base, which for this one is pi times r squared, which is 16. So that's the area of the base, and I do area of the base times the height. And once again, the height is measuring the distance from one base to the other. So the height on this one is going to be that 10. And now I can go ahead and plug away on this thing. So the volume equals 160 pi, and that's cubic meters. Okay? And for this particular example, I could leave it in terms of pi. That would be the exact answer. If it makes more sense to round it off as a decimal, really it depends on what the use of this is. If I'm using this volume to find something else, I want the exact value. But if I actually just want to have a general idea of the actual volume, it's probably better to write it as a decimal. So 502.65. And once again, that's cubic meters. Okay? So there's the exact value and the rounded off volume. If we look at this guy, for this one, this is a pentagonal prism here. And so as we look at this thing, the bases of this have to be the pentagons on each end, okay? These are the two sides, when I look at this pentagon and this pentagon, these are the two sides that are parallel and congruent, okay? So those have to be the bases, all right? And so if those are the bases, the distance between those two is the height. Okay, and so for this particular one, the height is actually this guy over here. It's that 11. That's the distance between the bases, okay? And so for this one, the volume equals area of the base. And for this particular example, area of the base is not as cut and dry as it was with some of the other examples. This one's a little bit more involved. Let me draw that pentagon off to the side here. And so if we're thinking about this pentagon, it's a regular pentagon. We'll assume that it's a regular pentagon. So all of these are 6 centimeters. But now in order to find the area of this pentagon, I have to do 1/2 the apothem times the perimeter. The problem is that I don't have the apothem this time. And so for this one, I have to draw my apothem. And again, this involves kind of doing a little bit of triangle work here. So once again, as I start to look at this triangle, let me relabel some of these pieces. This would be 3 centimeters, okay? And now from here, I have to find the missing piece right here. I'm going to use some of these angle measurements again. And so for this one, the angles inside a pentagon are going to add up to 540. If you divide that by 5, each angle is 108, which means this little angle down here is a 54 degrees, okay? So that guy right there is 54 degrees. Let me draw that triangle off to the side. And so it's almost like I'm just zooming in further and further so I can see this thing a little bit better. But here's the situation I have. Over here, that's the apothem. I can use my trig functions in order to find this guy, okay? So for this one, the apothem, if I do the cosine of 54 degrees, the tangent, I don't know why I'm doing cosine here, crazy guy. I don't want the radius, so I want the tangent of 54 degrees, because again, I'm looking for the opposite side. I have the adjacent side, that's going to be tangent, so tangent equals opposite over adjacent, and now I cross multiply and solve. I find out that A equals 3 times the tangent of 54 degrees, and that will eventually be a job for my calculator. I'm just not ready for that yet. Okay, I'm going to leave it in exact terms till I'm ready to plug this whole thing in. So here, back to volume. Volume is 1/2 the apothem, which is the 3 tangent of 54, times the perimeter. The perimeter of this thing, because it's a pentagon and each side is 6, that's going to be 30. Okay, so that's the area of the base, 1/2 the apothem times the perimeter. Now I need to take the area of the base and multiply it by the height, which we established quite a while ago as being that 11. Okay, so the 11 here is the height. And now this is a job for my calculator. Make sure your calculator is in degrees, and let's plug away. Let's see, 1/2 times the 3 times the tangent of 54 degrees, and then times the 30 and the 11. Okay, so I plug everything in, and I get volume equals 681.31, and that's cubic centimeters. Okay, so once again, we're just drawing on all of the knowledge we have in terms of finding area of different things, finding area of regular polygons, that whole 1/2 the apothem times the perimeter. I needed to use trig functions within that to find this particular example. And so now I take the area of that base times the height, and that gives me the volume. Okay. If we look at this one, we want to find the volume of this thing. And there are two ways to approach this particular example. We could look at this and say, hey, let's look at each of these individually and say, you know what, this is two separate prisms. They're kind of stacked on top of each other. We just have to add the volumes together. So notice down here, I've got this rectangular prism at the bottom. And then up top, I have a triangular prism on the top. So I could just find the volume of each of those individually and add them together. So let's start with that method. That's probably the easiest way to think about it. And so the volume of that rectangular prism, I could use any one of these sides as the base. So if I called this guy down here the base of this thing, okay, so the volume is the area of the base, which is 6 times 13, and then times the height. So if these are now my bases, if I used the top and bottom of the base, the height is the measurement that measures the distance between those two. So for this one, it's going to be that 5 centimeters. Sorry, I was trying to erase. And I just go ahead and plug this in. This is the easy one. That gives me a 390, and that's cubic centimeters. And now from here, now I have to shift my focus to that top prism, which is that triangular prism. And it is a triangular prism. I have to use the triangles as my bases for this thing. And the reason those have to be the bases is because, once again, those are the two sides that are the same, all right, that are congruent and parallel to one another. So those have to be the bases of this thing. Okay, so these are the bases that I'm looking at. Which means when I start talking about the height of this thing, the height is the measurement that measures from the distance from one base to the other base, which I can steal that from down here. It's 13 centimeters. So some of this is a matter of kind of looking around and borrowing the measurements from other places as we kind of construct this thing. All right, so now the volume of the triangular prism is the area of the base, which is 1/2 base times height for the triangle. And for this particular triangle, when we look at this thing, I don't really have the base or the height of this thing the way it's written right now. I got to kind of find those pieces around here. And so if I start to transfer some of this, let me kind of erase that guy. I can take this 6 right here that comes up here. This 5 centimeters would be the same as this guy right here. And so I have all three of these dimensions. So the 6 is really the base of this thing. Okay, so I now have the base by moving some of the measurements around, but I still don't have the height. The height of this thing would be this guy right here. Okay, and so once again, I have to drop this altitude since this is an isosceles triangle. When I drop that altitude, what I end up with is a 3 centimeters here. Let me kind of erase this. I just have to look at this triangle individually. So the whole thing was 6. I got a 3 centimeters and a 3 centimeters. Well, now I need to find this height. Well, again, that's going to be a job for my Pythagorean theorem when I look at this thing. And again, if I kind of just scoot that off to the side, I always like to kind of draw these off to the side and give myself a little bit more space. 3, 5, and the height is here. Okay, just kind of zooming in on this thing. Well, let's use our Pythagorean theorem. So let's see, 5 squared is the 25, minus 3 squared, which is 9. So 25 minus 9 is a 16. The square root of that, when I do my Pythagorean theorem, I get a value of 4 right here. Okay, so now I actually do have the height of that triangle as 4. And so that's the area of the triangular base. So remember, volume is area of the base, which is what I have right now, times the height. And we already established a while ago that the height of this thing is going to be 13 because that's the measurement from one base to the other. Okay? And so now I just plug away here. Once again, the volume of this triangular prism. Let's see, that's going to be, just plug it into my calculator real quickly. 156 cubic centimeters. And so now if I want the total volume, I just have to combine these guys. It's essentially like volume addition, just like we have segment addition or angle addition or area addition. Okay, so it's just a matter of adding these guys together. And that's going to give me a 546. Okay, and that's the overall volume of the whole thing. Okay, no need to round off or anything like that. All right. The other option, if I kind of just hit the reset button on this thing, and I don't think this is as good of an option typically for most students, but you could look at this thing as one complete pyramid, one complete prism. And so if you looked at the values that I have here, you could find just the area of this whole thing, which still involves area addition. It involves coming up with the area of this guy over here. This piece right here is 30 square inches. And then this triangle up here, if we kind of borrow from right here, as a 12, sorry, I said square inches, square centimeters, which means this the entire area of this, if we consider this the base, because look, here's an identical piece on the other side, so those are the bases. So we could say, hey, the base of this thing, well, those do added together, so the base of this thing is 42. Well, then I could find the volume, say, hey, it's area of the base times the height, which is now that 13 again. Okay? And again, if I plug that into the calculator, it gives me the exact same value. It gives me the 546. Okay? And so you could think of this as one prism altogether. You still have to do a little bit of addition in order to find the area of just the base, though. Okay? If I look at something like this guy, once again, I'm in that similar situation of I could try to find the area of this whole piece right here and just treat this like a prism and say, hey, I've got these two sides over here that are identical, and I could find the area of that times the height. But it's really easier to think about, I think, for most students by looking at this as two separate pieces. Okay, and so if I look at this bottom piece down here, let's say that this prism right here, if I kind of viewed, that was terrible, if I kind of viewed this guy as a separate piece, kind of filling in this rectangular prism that's at the bottom, I could use this guy and this guy as my bases. And so when I look at this thing, here's 8 inches. So the base of this thing, so if I look at the volume once again of the rectangular prism, or this one actually is a square prism, its area of the base, which is 8 times 8, times the height. And again, for this one, because I used those two pieces as the base, the height is the distance between them, which is the 12. And again, I can just plug this into my calculator. That gives me a 768. And now from here, I just have to find the area of that half cylinder at the top. And it is a half cylinder because, again, I don't have the whole thing. I just have half this cylinder. And so really, I'm just going to find the area of that, the volume of that cylinder. Okay, if I kind of draw this kind of separately, if I find the area of that cylinder and cut it in half, well, that's the area of that that volume of that top piece. Okay, and so if I look at the volume of that top piece once again, it's that cylinder. So the volume of the cylinder itself, remember, is pi r squared times h. The radius of this thing is going to be 4 this time. It's halfway across here. Okay, so instead of the 8, it's a 4. So pi r squared times h, the height of this thing is 12. But again, that's the area of the whole cylinder. I only want half a cylinder, so I'm going to divide that by 2. And once again, for all intents and purposes, I'm just going to leave this in terms of pi until I'm kind of done with the thing. Okay, so 16 times that guy. Let's see, that's going to be a 96 pi. And now for the end result of this thing, this is where I'm going to just go ahead and add these two together. Okay, so the volume is going to equal these two added together. And now this is where I'm going to go ahead and plug it into the calculator. Okay, there's no need to plug it into the calculator before this because really then I'm using a rounded off answer that might affect things as I go. Okay. So the volume here, when I add these together and plug it into my calculator, gives me this guy. Okay, so we find those two pieces individually. We look at the pieces and say, okay, this is a rectangular prism. This is what looks like half of a cylinder. Find the volume of each of them individually, and then add those volumes together. Okay.